When dividing radical expressions, you also want to make sure you are lining up corresponding parts and not just putting numbers together. For example, this first one has the radical of 18, and at the bottom is just a plain number 6. So even though 18 is divisible by 6, since 6 does not have a radical, you cannot put them together. The only thing you can do is simplify the 18 as much as possible, which we know breaks down into 9 times 2. We also know the square root of 9 is 3, so he's going to get kicked out. We're going to keep the 2 and bring down the 6. Now that we're here, though, the 3 and the 6 are both technically outside of the radical, so those can get simplified to a 1/2, and we're just going to leave the square root of 2 at the top there. Now let's look at this second one down here. Now here you can see there's a radical at the top and the bottom, and I know 54 is in fact divisible by 6. So I can do 54 divided by 6, and I know that's going to give me the square root of 9. The square root of 9 I know is 3. Does it always simplify down to a whole number like that? No. But if the numbers work and they're both radicals, you can go for it and then simplify it from there. Here on this third one, it's showing the radical completely covering the top and the bottom. That's really just another way to say that you're taking the square root of the top and you're also taking the square root of the bottom. These are perfect squares, so I'm going to go ahead and work them out. The square root of 9 is 3, and the square root of 49 is 7. So that would be my final answer for this one. Let's try another. Here we have some additional radicals. I do know that 48 is divisible by 3, and they're both under the radical. So I'm going to go ahead and put them together. So it's still going to have a radical. 48 divided by 3 goes 16 times, and then I still have x cubed. Since the index is technically a 2, I'm going to break down my x cubed to be just x squared and the leftover one, and then I'm going to continue to process out. So the square root of 16 I know is 4, the square root of x squared I know is x, and then I'll be left with the square root of x under the radical. Now in this last example, 25 cannot be divided by 7, so there's no point in trying to do it that way. I can take the square root of 25, so I go ahead and do that. But then I still have this radical of 7 in the denominator, and this is one of those things that math does not like. There's just certain things and we just do not do, and we do not leave our answer in certain ways. And one of them is radicals in the bottom. We do not leave our answers with radicals in the bottom. So we're going to do something called rationalizing the denominator, which is a fancy way of saying get rid of the radical. And the way that you do that is simply by multiplying the top and the bottom by the exact radical you're trying to get rid of. And the reason you do that is because whenever you multiply a radical by itself, the radicals disappear and you're left with just 7. Well, why is that? Well, that's because 7 times 7 is 49, and the square root of 49 is 7. At the top, we're just multiplying straight across, just like fractions. Top times the top, bottom times the bottom. I get 5 square root of 7, and there's nothing else you can do here to make this any smaller.